Hello, this is James reporting remotely for the Hatter Planetarium. Welcome to this video update on some exciting recent astronomy news. Last month, several astronomy publications reported that a significant quantity of the molecule phosphine had been discovered in the atmosphere of Venus. Phosphine has been proposed as a bioindicator chemical, and research continues to narrow down the possible causes for its presence on Venus, which has long been assumed to be uninhabitable. This video will discuss the historical background of our search for carbon-based life on Venus, the significance of this recent discovery, and what impact it may have on future astrobiological research. Part 1. Venus. Venus is the second planet from the Sun, and most often the closest planet to Earth, though sometimes orbital geometry means it is either Mars or Mercury. Because of this, and because the two planets are similar in their size and rocky compositions, Earth and Venus are often considered sister planets. Venus' proximity to Earth makes it one of the brightest objects consistently visible in our night skies, and its similarities to Earth made it an early candidate in humans' search for extraterrestrial life. In fact, Venus became the first planet that we reached by space probe, when Mariner 2 flew by in 1962, relaying back information about Venus' temperature and atmospheric composition. The ultimate result of this exploration, however, was that we deemed Venus to be categorically uninhabitable to life as we know it. After losing contact with lander probes that were crushed under its immense atmospheric pressure, and finding little to no evidence of H2O anywhere on the planet, Venus has long been assumed lifeless. Part 2. Phosphine. So what was this chemical found in the atmosphere of Venus that has people so excited? After all, phosphine is a rather unassuming chemical in its appearances here on Earth. It is rare, and it is more often a byproduct of organical chemical reactions than it is a necessary component of them. However, it is strongly tied to one organic process that is as ubiquitous as life itself: decomposition. Phosphine, as you can see here, is a trigonal pyramid, meaning its four-dimensional shape has four sides, all triangles. It is comprised of one phosphorus atom and three hydrogen atoms, and the presence of phosphorus makes it a highly reactive molecule. It is formed in decomposing organic matter when phosphorus is present, and decomposition processes begin to shift the chemical properties of the existing molecules. Needless to say, if Venus is lifeless, there is no organic decomposition taking place there. Therefore, scientists needed to consider and rule out all of the other plausible explanations for its presence in the atmosphere. Dr. Clara Sousa, an astrobiologist at MIT and one of the leading researchers in the articles published detailing the Venus discovery in September, has dedicated much of her career to studying phosphine and using chemical spectroscopy to identify it elsewhere in the solar system. Spectroscopy, briefly, is a process by which we can detect the presence of certain elements due to the specific wavelengths of light that they absorb. Before last month, we had only detected it in the atmosphere of gas giant planets like Jupiter, where the immense heat and pressure can naturally simulate the laboratory conditions required to manufacture it here on Earth. Venus, though it does have an extreme atmosphere relative to our own, simply does not have these same requisite conditions. And we would expect any non-self-renewing quantity of phosphine in Venus' atmosphere to have been long dissipated due to solar radiation. Nothing is definitive, but there is compelling evidence that the phosphine detected in Venus' atmosphere is a biosignature, a sign of life on the planet currently. Otherwise, it is coming from an as-of-yet unknown chemical process. Either way, this discovery represents enormous progress in the fields of planetary spectroscopy and astrobiology. Part 3. Supernatural Implications. In my research on phosphine, I came across a connection between the molecule and human mythology that I found way too interesting not to share. As I said before, phosphorus is a highly reactive element. This property sometimes causes high concentrations of phosphine gas to oxidize in the surrounding air in a chemoluminescent reaction. Ignis fatuus is the Latin name for this phenomenon, and it is known around the world under a number of names, including Aleia, Chirbati, Hitodama, Min Light, Brujas, Ghost Candles, and perhaps most commonly, Will-o'-the-wisps. Throughout human history and around the globe, appearances of ghastly light near graveyards and decomposing forest ecosystems have long been associated with spirits. The connection between death or spirits or ghosts is no mystery in the modern day, as we now understand that phosphine occurs most commonly as a byproduct of decomposition. Ecologies like graveyards and the forest floor have consistently high levels of decomposition, and it is no surprise, therefore, that there are relatively high concentrations of phosphine in the surrounding atmosphere. When the concentrations of this reactive gas become high enough, they react with the surrounding air, oxidizing in an ephemeral ghastly flash of light, known by its names like Will-o'-the-wisp or any of its several names around the globe. What does this connection suggest about potential life on Venus? It is hard to say for certain, but it may suggest an ecosystem that us Terrans here on Earth could recognize, one with hierarchical food chains and different forms of life playing different roles within an ecosystem. But again, this research is very new, and nothing is known for certain. If there is a form of life existing somewhere on Venus, it is likely microscopic and specially adapted to what are very harsh conditions towards life as we know it, what we would call an extremophile. But its existence would suggest that carbon-based life may be far more common in the universe than we would have previously imagined. If life can persist under the extreme conditions of Venus, this would expand the range of what astronomers consider habitable planets in the search for extraterrestrial life. But even if life on Earth is not unique, that doesn't make it any less special. Our planet precariously sustains the conditions for complex life in ecosystems spanning air, land, and sea, and it is unlikely we will ever be able to visit another planet so well suited to our needs. For my part, I know that the next time I'm outside, I'll remember our new potential Venusian neighbors and take a deep breath with a newfound appreciation for fresh air. This is James, signing off remotely on behalf of the Hatter Planetarium. Thank you for watching.